All right, we're back for day 9 of Advent of Code. Here we go. Okay, file checksum, file compacting process, give a bunch of blocks, ID number, based on the order of files where they appear before they're rearranged. 1 through, okay. 1 block file, 3 block file. How many blocks? Alternate between indicating the length of a file and the length of free space. Okay. 1 block file, 2 with 2 blocks. Yeah, okay. I see. Or I see, yeah. From the end of the disk to the leftmost free space block. Oh, interesting. Position with the file number ID. Okay. So I guess from the end of the disk to the leftmost free space block. Okay, well I guess let's just do it. No. Okay, so the ID okay, do this and then this of if fill D of D X I, pick terrible names here, I have no idea which is what. Cur plus I is equal to ID. We start at 0, that's true. Otherwise, I think we just do this. And then what we do need to do regardless is cur needs to increase by dx. Okay, so we have, this is our file system, and now I think what we just do is find the max key, obliterate it, and then find the min key that's free. Yeah, seems fine. Wait, first, how long is this? Shoot. I wrote, oh my god. Okay, that is gonna be a little rough to do quadratic, but that's fine. Yeah, okay, seems fine. So we get this, and then we do, we're gonna move to the leftmost available position. So delete it, and then find the leftmost available position. And then add it here, d of pos equals id. I think if pos equals rm, then we break, and then the answer is just going to be the checksum. Add the result multiplying each of these blocks. Okay, so this is going to be for make sure I get rid of that. Shoot. Could we be looping infinitely? Unclear. I think the leftmost. A simple optimization is we can pick up where we left off. Yeah, we should pick up where we left off. I'll just call it plus. At some point we end up with an empty one, we put something in there. If it was where we started, then we break. Fine. I guess I'll get the pipe going. It's there somewhere. Oh, there's a number. Rank 118, so close. Okay. Attempt to move the whole file to the leftmost span of the free space. Attempt to move each file exactly once in order of decreasing file ID number. If there's no space, the file does not move. Okay. In order of decreasing file ID numbers. Okay. Alright, I'm gonna need a map from file ID to where it is. So I think when I'm doing this, also for starters, I should just copy all this. Okay. When deciding if it fits, I should just represent these as segments, I think. Oh, it's going to take a little while to write. It's not great. But I think we should still do that. If will be exclusive on the right index. Otherwise, okay, so then we have our segments. And I think the question now is maybe going to be, I should still keep this. I need the ID. Whenever we fill something, we have to increment the ID. Okay, let's put the ID in here too. Okay, now we have our segments. And now the question, so we are going to go through the let's make this a dictionary instead. Key it by the ID. Okay, fill in the cache. Cache is gonna be a dictionary. Okay, and then the order that we're gonna go in is just going to be segment keys sorted in decreasing order. Okay, and then for each segment, what we're gonna do, we're gonna see if we can move it. Leftmost span of free space blocks. No space, span of free space to the left. Oh, so you move it as far to the left as you can. This is not going to be very efficient. Shoot. Oh. Okay, well, what we're going to do. Oh, man. Yeah, let's just try all possible positions. I don't know. So we have this start, cur, end will be the segment, this current segment. While we are still less than this, we're going to check, can we fit position here? Or can we fit the segment at this position? And for that, our requirement is that cache of pause plus I, or pause plus I not in cache, for I in range segment length. Then we can fit it, and if we fit it, then we need to remove it from the previous cache. First of all, if we can't, then we just do this. Remove it from the previous. Remove the previous thing from the cache. And then moving it to pause. Pause plus cur e minus cur s. S is our segment ID, I think. Okay, and then when we're done, cache should just be good. This is now going to be the cache items, and we've deleted the keys, so I think fine. That's not great. That's really not great. Something needs to be. We're trying to delete something. Okay, the very first thing, when we're trying to delete it, it's not working so well. We currently think this is at these positions, 94794. Doesn't have this in it. That's weird because I set cur. Cur is not being incremented. Cur is being incremented regardless. If fill. What does have it? It's at positions 8 and 9. Oh, I need a break. Oh crap, that's really important. Okay. I think we need to pi this. There's a number. I was definitely too slow on this. Rank 84! I got points! I got points for the first day in a while. Oh man. It was not that high of a finish, but I am so happy about that. I have just not gotten points in the longest time. Oh man. Yeah, definitely part 2 here. I feel like large language models might struggle on this, but I'm really not sure. Even the first part, I felt like they should. But let me look at the times on the leaderboard. Okay. 1 minute and 11 is crazy. 27 seconds is just really crazy. I'm pretty sure this person said they weren't using a large language model though, so that's kind of wild. I just can't even imagine being that fast on the first part here. Although I guess to be fair, I was really slow. I was not going at super great speed on the first part. Yeah. Oh man. Okay, maybe now I should think about. I'm a little curious now what the proper way to do this is. I definitely wrote a bunch of code, and it is some terrible code, and I picked some of the worst names possible. On my first pass, I don't know, I felt pretty pressured, and this is old. And I definitely picked a lot of one letter variable names that were not good, and I couldn't remember what they were. Like, what was D? Oh, well, that's my mapping, obviously. That was like very not good choice. And on my second pass through, I picked longer names, and it maybe slowed me down a little bit, but I don't think it slowed me down a material amount. The break bug cost me maybe, I don't know, there's no way that cost me more than like, how long, I had a wrong submission? Did I? No, I had an error on the second part. I didn't have any wrong submissions. So it didn't cost me a minute, I don't think. It maybe cost me like on the order of 10 to 20 seconds. And that would have been, yeah, that's like not that big of a difference here. Interesting that, I'm just skimming it, but it seems like there was maybe a cluster of times here and then a pause, but maybe that's not true. Certainly, oh yeah, we're at 100 now. Yeah, man, that was a cool day. Happy that I got points. Yeah, sorry, so back to the question. The first part is kind of just implement a thing. I guess there's like some amount of, this is a little slow if you write it in like a pretty naive way. And yeah, I don't know. I still wrote it in a pretty naive way. And basically they give you some spec and they tell you that there's like numbers in different places, and then you just want to like always find the rightmost number and move it as far left as it can go. And you kind of just do that. I guess like the one mini optimization that I think was necessary was track the leftmost, like when you move this 9, finding the rightmost thing is pretty, finding the rightmost thing, I just did a pass through to find everything. I did not store it in a better data structure for that. And then moving it to the far leftmost as was empty, I just walked the all positions until we got to an empty one. And one optimization you can do is when you start walking, you can start at the previous place you stopped walking. That's just like a simple free optimization. That was me writing this pause here and then not resetting it to 0 in here. And yeah, and that part you just sort of do it. The stop condition is like whenever you, so the way I figured out I did the stop condition was I delete the element first, then I place it, and then I check to see did I place it exactly where I deleted it. And if I place it exactly where I deleted it, then you know you're done. So that's nice. In part 2, they then say, now you move the whole segment at once, and the whole segment, like it has to move somewhere it can fit. So if you have a really big segment, like these 8s, they just cannot move anywhere, so you just sort of leave them where they are. And you consider each element once in a decreasing order file number, which is again like a just do it thing. For the first part, the representation I used was like a mapping from location to what's there, if anything. And then for the second part, I still kept that mapping because you do want it to efficiently check, like, is this space empty? But I also added like a list mapping the lengths of these segments. I guess, yeah, so what I did here was pretty messy, and maybe it's worth trying to rewrite it a little bit more clean. Certainly, I don't know how I feel about checking in code with this variable name. So let's try and rename this a little bit. I think the thing that I actually want here, like when I use this mapping, all I'm using it for actually is, I believe, to get the length. Yeah, I use cur_s, cur_end. I guess I do need the starting position. Yeah, this might be a little bit better to like instead store the length. What are they actually? They're like files. Why not? I'll call them files. Files, disk, next disk location, next is file, next file ID, and then for digit and s, if the next thing, so I use this next is fill just to toggle back and forth between filling and not, because the spec here is that this is like, I don't know, like run length encoded sort of. Every alternating one is a gap, is like how far the gap is. So, and then files of next file ID. Yeah, I'll store the location and the and the length. I should call it length. Next this location and length, and then for disk of this location slope is going to be the next file ID. Next file ID plus 1, and then next is fill equals false, else next is fill equals true, and then next disk location length. Wow, code can look so clean when you actually give it better variable names. I didn't even change any of the code here, really. And then files to compact. Yeah, I guess this can actually just be I don't know how I feel always when I'm writing this like -1, -1, -1 thing, but for like, I don't know how I feel to see this in production quality code. It's a little bit vague, but it is what it is. Yeah, I didn't really need to sort it. It sorted for no reason, kind of. And then for I actually didn't need the enumerate. I started writing the enumerate just so I could print out how far I was because I had no idea how slow this thing was. But I think it's just file ID, and then yeah, we're just like trying to find this insert position, and then I should comment out this. Cool. And then it's less than initial location, which is just going to be files of file ID of 0. So it's going to fit if insert position plus I not in disk or I in range. That's the length of the file. If it fits, then yeah, using a name tuple here would probably be better, but I'm trying to write like cleaner code, but I'm not writing the world's cleanest code here. I'm not going to bother with the name tuple. So go through this. Just going to delete the disk of not insertion position, the initial position. Every file moves exactly once. Yeah, I don't know. Maybe tracking both the start and the end was actually like more elegant than I thought it was because I could write this like cleanly. I'm not really doing anything other than like adding names to my variables right now, to be honest. I thought it would be cleaner if I stored the length and not the end position, but you kind of do want the start and end position here. Otherwise, you have to like compute them again, which is a little bit annoying. This is an offset. I guess offsets can have one letter variable names as a treat. So delete disk, the file here, plus our offset starting position, and then while we're at it, we can also actually just do and then otherwise check the next insert position. And then we are done. So location and the file ID. Length. How fast is PyPy here? I think it was pretty fast, right? Okay. Adding this, like the try catch on the PyPy or on the paperclip thing, so that I could actually run PyPy without needing to comment out code. Actually game changer. It doesn't cost me that much time, but just the mental overhead of having to like do that is pretty annoying. I don't think I made my code any slower, but I'm really not confident. Oh, it was stuck because DOS is like that sometimes. Cool. These, and then the first answer, I don't know. I didn't find this actually that interesting, the exercise of going through writing the cleaner code. I really just gave variable names to it and retyped all my code. Yeah, I don't think there's really much to say about like how interesting this problem is. I guess there's some interesting bits, and if you want to do it like really efficiently, then what do? You probably want to keep track of like, I guess you could keep track of like a linked list of the current length of free spaces here by their size. I mean, what you really want to be able to do is answer quickly queries of the form, what is the earliest empty segment of length at least 4? Where 4 is like whatever the length of the current segment you're looking at is. There might be some hacky optimizations that abuse the fact that files can only be a maximum of length 9 bytes or 9 memory addresses. Yeah, I guess that means. That also gaps can only be at most 9 distance. Yeah, maybe if you had a mapping from length of gap to locations with that length or more, and that was a linked list, you could pretty easily answer the query. If you have a length 7 segment, you look at the mapping for what are the free positions with at least length 7. You see that, and then you jump there, insert the file, and now the question is, can you maintain this data structure easily? I think you can. I think what you do is for 7, 8, 9, you need to. Oh, it's a little annoying because you want to keep like a mapping from location to the node in the linked list. You want to quickly like remove it from the. Oh wait, no, it's the earliest of that length or longer. Yeah, it must be the case that if you have this linked list that says for length 7, your free spots are 1003, 1233, 1455, and so on. And you're going to insert the file here. You can quickly just pop this off of the front of the linked list, and now this is good. When you're inserting something here, it might be the case that this free spot actually had length 8 or 9. If it had length 8 or 9, oh yeah, this is annoying. If it had length 8 or 9, then you're going to have to insert a new thing in the for length 1 and for length 2 in these entries. And the problem is you might have to insert it somewhere that's not at the front. Maybe you want this to be a heap instead of a linked list, like a min heap, because then you can insert really quickly. And you can still pull off the bottom element, which is all you ever need to remove from. I think that can work. And that can get you pretty quick. Like, you can really quickly figure out where to put a file. You can really quickly also update the data structure. So I think that should work. I do not care to implement this right now, so that I will not do. But I think it should work. If it doesn't, maybe someone in the comments just yell at me and tell me why it doesn't work. If I decide I'm sufficiently motivated, I might like try and write that, and I'll like put in a pinned comment or something. Cool, but yeah, that is all I have for day 9 of Advent of Code. See you all tomorrow.